Hi, my name is William from emew, and today I'm going to be talking about etching and pickling and the production, economic, and environmental benefits that emew electrowinning technology can achieve in acid finishing processes. What is etching and pickling? Well, simply, etching and pickling are surface treatment processes where a metal product in different forms, flat roll products for instance, sheets or coils, long products such as bar or wire, tubular goods, or forged or cast products are finished in an acid solution. Whenever a metal product is subjected to hot working activities, rolling, extruding, casting, welding, or annealing at the metal's scaling temperature, oxygen will diffuse into the material and form an oxide layer. And acids are used to dissolve this oxide layer to restore the surface of the material to its original composition. Pickling is considered to be a heavy treatment in that a significant amount of metal can be removed or dissolved from the material being pickled, typically on the order of grams per square meter of surface area. Etching also requires the use of acids, but the difference is where pickling removes these oxide layers and areas of elemental enrichment or depletion from the material, etching imparts a very specific surface finish in the production of battery or capacitor materials. For instance, the aluminum or copper that's used has to have a very specific surface roughness, and acids are used to impart that surface finish that's required for the application. In comparison to pickling, etching is considered to be a light surface treatment process where the material being dissolved from the material is typically on the order of milligrams per square meter of material. Pickling or etching wastewater is simply the liquid waste solution that's generated from the pickling or etching process. More specifically, it is a very toxic and corrosive solution containing a significant portion of strong acid. This could be sulfuric, hydrochloric, nitric, or combinations thereof, typically on the order of 5 to, in some cases, greater than 20% of concentration by volume. Dissolved metals, these could be iron, nickel, chromium, copper, zinc, etc., from the 1 to as much as 5% by volume, and trace organic components such as surfactants, antifoams, inhibitors, or levelers, typically in trace amounts. In industry, pickling or etching wastewaters are commonly referred to as either being spent solutions or acidic rinse waters, depending on where the solution originates from in the process. It's important to note that pickling or etching solutions have a finite life, and that over time, with production, the acid and metal concentration of the solution changes. The acid concentration decreases, and the dissolved metal concentration increases. This has an effect of slowing the finishing rate or production to a point where it becomes non-productive. And it's at this point that the bath is considered to be spent and must be replaced. And as I'd mentioned previously, this spent solution is this highly acidic metal-rich waste that generates from the finishing process. In addition to the primary waste, the spent solution that's produced from the finishing lines also produce another waste acid stream from rinsing activities. After pickling or etching or passivation, the part will then be immersed in or washed down with fresh water to remove that acid solution from the material. And in comparison to the spent solution that we talked about previously, rinse waters are also considered to be acidic, but are lower in acid and metal concentrations, typically less than 5% and typically less than 0.5% of metal. Wastewater from finishing lines are typically managed in two different ways. The first way being offsite disposal. In this scenario, once the pickling or etching solution is considered to be spent, the solution is then pumped to a tanker as a liquid waste that is then transported to an outside facility. The outside facility then manages this waste through any number of means. These could include neutralization, recovery, or direct disposal in a deep well or other specialized landfill. Offsite disposal and treatment is the most expensive option due to the characterization of the wastewater, it being highly acidic, corrosive, and toxic. In some cases, a credit may be given to the finisher for the metal value contained in the waste solution to help offset the cost of disposal, However, it's to be noted that in this case, the metal value that's given is often a fraction of the current market value. In the second scenario, these wastewaters can be treated on-site. In this case, the pickling or etching solution would be transferred to the on-site waste treatment facility. The wastewater is then treated to neutralize the acid and to precipitate the metals by adding a form of alkali, typically caustic soda or lime. The treated water is then discharged to the sewer, and the precipitated metal solids are collected and sent to a disposal site for landfill. Compared to off-site disposal, on-site treatment is typically less expensive per cubic meter, but requires the operation of a waste treatment facility by trained operators. The solid waste that's generated after treatment requires removal or disposal, but at a significantly lower cost than off-site disposal, as in many cases, the solids that are generated are considered to be non-hazardous after treatment. In the above two cases, whether on-site or off-site, treatment still requires a significant handling of the acid, neutralization chemicals such as caustic soda and lime, and still generates a solid waste that must be hauled away and disposed to at a secure facility. Does technology exist for the recovery of pickling or etching wastewaters? And the answer is yes. For spent solutions, technology based on either ion exchange or membranes, this would be diffusion dialysis or electrodialysis technology, these systems can separate the dissolved metal from the acid in the spent solution and allow a significant proportion of the solution to be reused in the pickling or etching process. Typically, utilizing this type of recovery technology can reduce the overall waste disposal volume and cost, 35 to maybe as much as 50%, in addition to reducing the acid purchases, 40 to 60%, and provide some upstream operational and production benefits. However, a complete closed loop recovery is not achievable using this type of technology in all cases because the metal fraction that is generated from these recovery systems still requires to be neutralized, converted to a solid waste, and then is disposed of. The emew smart system electrowinning technology can be utilized in copper or brass pickling processes to recover 100% of the spent pickling or etching solution. In the emew process, the spent solution is sent directly to the recovery process where copper is recovered in a high purity metallic form that is suitable for either on-site reuse or as a saleable byproduct. And the acid component is then recycled directly back to the process for reuse with zero losses or volume adjustment. The emew smart system offers significant benefits over other technology, principally a closed loop system generating zero waste, in addition to producing a high purity saleable byproduct. In this slide, you can see the main economic benefits of the emew's closed loop process versus traditional technology. As can be seen from the data, the emew process not only saves $31,500 a year in acid, but also generates $297,000 in annual revenue from the copper that is produced from the process. ROI is typically less than 2 years. Are there any other benefits other than waste recovery? Absolutely. From an operational perspective, the emew system offers many advantages, which would include eliminating the downtime required for tank dumping and makeup, improve product quality by optimizing and stabilizing the pickling bath chemistry, increase production throughput by maintaining a lower metal concentration, reduced reworking of materials due to surface defects when the pickling solution or etching solution gets out of specification, and importantly, a very consistent pickling time due to the constant copper concentration that's maintained and the constant acid concentration that's maintained in the pickling or etching process. Financial benefits, including reduced acid purchases by regenerating the acid, reduced need for haulage and disposal of the neutralized solids, potential reallocation of human capital, reduced waste treatment costs overall, and obviously taking advantage of the value that's contained in the metal byproduct that's produced from the emew process. And finally, ESG benefits. Significantly less waste generated from the pickling line, reduced fresh acid storage requirements and management, and eliminating the need for waste acid handling. In summary, I hope this information presented to you has been useful, and if there are any individuals who would like to know more about how emew can bring these benefits to your pickling process, please don't hesitate to contact us. Thank you.